All right, so this first example, what we want to do is we want to find the greatest common factor for those three terms. All right, you've got three terms here that are separated by addition and subtraction. So there's one term, two terms, three terms. So what's the largest number that divides evenly into 8 and 4 and 2? 2. So that would be part of the greatest common factor. So we would have a 2 right here. And then it says how many x's do they have in common? Well, if you remember from before the break, I talked about when you get the greatest common factor, the variable has to be in all three terms. So the variable has to be in each term, which it is. And then you factor it out to the lowest power that it appears. So what's the lowest power you have on x? A 2. All right, good. So you got to have, again, the x has to be in all three terms, which it is. And you factor it out to the lowest power that it appears, which would be a 2. So that means your greatest common factor would be 2x squared. Okay? And then I'm just going to go right to the examples from here. So let's go example 1 here. So when you look at example 1 there, what's the largest number that divides evenly into 2 and 4?
2.
That's a 2. And then do you have an x in both terms?
No.
No. So you don't factor an x out then. And then you're going to make a set of parentheses like this. And do you see that you're really doing kind of like the distributed property backwards? So you're going to say 2 times what would give you 2x squared? What's that? Good, yeah. It'd be x squared. So you put x squared here. And then you would say 2 times what would give you negative 4? Good. Tom, that's good. So a negative 2. And then that's it. Do you see how you kind of did the distributed property backwards? You took it back apart, so it's called factoring. And you can check your answer just by distributing really quick. So hopefully you see that if you do 2 times x squared, you would get the 2x squared. And then if you do the 2 times the negative 2, you would get the negative 4. So you can always check these. Another way to think of it, it helps some people. What you do to figure out what you're going to fill in right here is you take the first term, this one, and you divide it by the common factor. So that's another way to think of it, is you could do the first term, which is 2x squared, and you would divide it by your greatest common factor out in front, which is a 2. And same thing for this one. You would take the second term, which is negative 4, and you would divide that by the common factor that's out in front, which is a 2. So that's another way to think of it if you're trying to figure out how to fill that in. Well, let's try the next one. So what's the largest number that divides evenly into 8, 4, and 16?
4.
That one's a 4, good. So you're right, 4. Is there an x in each term?
Yes.
What's the lowest power that it appears to?
Squared. 0x.
1, right? First term right there. First power. So the lowest power that the x appears to is x to the first power. And then you're going to fill in these parentheses, but there's going to be 3 terms inside there. So then you ask yourself, 4x times what would give you 8x cubed?
2x to the second.
Good. Yep. It'd be 2x to the second power. And then you would say, well, you could do it this way too. You could say 4 times what would give you negative 4? What's that? Negative 1. And then you could also say then x times what would give you x squared? Good. And again, if you're having trouble with that, you can always do it this way too. Like if you want to fill this one in right here, what you can do is you can take that third term, which is negative 16x, and you can divide it by your greatest common factor that you have out in front, which is the 4x. And what would that give you? Negative 4. Good. So that's another way to think of it right there. And again, if you ever want to check any of these, all you have to do, like if you want to check that last term there, you could do the 4x times the negative 4, and you should get the negative 16 that you have right here, right? Negative 16x. So 4x times negative 4 would be negative 16x. All right, let's keep going. We gotta do like 3 more. So this one, what's the largest number that divides evenly into negative 14 and, well, actually, just 14 and 12?
Negative
Yeah, in fact, they actually will do a negative 2. Now, you don't necessarily have to, but whenever all the terms are negative, so here you've got 2 terms and they're both negative, right? So usually when that's the case, when all the terms are negative, they will factor the negative out in front also as part of the greatest common factor. So we're going to factor the negative out in front. And again, what was the largest number that divides evenly into 14 and 12? That's a 2. And then we're just going to fill this in. So then you say negative 2 times what would be negative 14x?
7x.
Yep, 7x. Good. And then you say negative 2 times what would give you negative 12x squared?
6x squared.
Yep. And again, if you struggle with that, you can always do it with that division process that I showed you. I didn't do it for each term, but if you want to know what goes in right there, you take that second term, which is negative 12x squared, and you divide it by your greatest common factor, which is negative 2. And so if you want to go that way, you can see that this should be a positive 6x squared, right? Let me make a little more room for that. Like that. And again, if you want to check it, just distribute, do the negative 2 times the positive 6x squared, and you should get this right here, right? Negative 2 times positive 6x squared is negative 12x squared. Okay, then we'll do 4. So what's the largest number that divides evenly into 3, 2, and 10? Just 1, right? And is there an x in each term? No. This third term here does not have an x in it. So you can't factor out an x as a part of your greatest common factor because the third term doesn't have an x. And again, the largest number that divides evenly into 3, 2, and 10 is 1. So if the greatest common factor you have is just 1, then you say that this is prime. So you can't break that one down. That's kind of like when we were doing numbers. Like if you had 12, the number 12, you could write that as 12 times 1, or you could write it as like 4 times 3, right? Or you could write it as 6 times 2. So that means that that number's not prime, right? Because you could break it down into the product of, for example, these two factors, 4 times 3. That's why that number's not prime, it's composite. But if you have a number like 7, well, the only way you can write it is 7 times 1, right? And so that's a prime number. So if the only way to write that number is 1 times itself, it's prime. And that's the same idea here. The only thing you can do with this thing is write it as 1 times itself, because the greatest common factor for those 3 terms is 1. So that means it's just prime. So you can't write it as the product of 2 factors other than 1 times itself. Okay, and then we got to do this last one. This one, I don't know. It says that there's a court for the game of squash. I don't even know what that is. It's like I don't know how to play squash. It's like a handball court or like a racquetball court or something like that. So then what they want us to do basically is they want us to factor this thing right here. That's all. So they just want us to factor that. So what's the largest number that divides evenly into 9 and 6?
3.
A 3. And then is there an x in both terms? Yes. So that's a part of our greatest common factor. And then what's the lowest power that it appears to? It's the first power, which would be right here, right? So that's going to be an x to the first. And then we're just going to fill that in. So we're going to say 3x times what would give us 9x squared? What do you guys think? 3x times what would give you 9x squared? 3x, good, Tom. So you guys can see we really are doing the distributive property backwards, right? We're kind of undistributing here. And then 3x times what would give you positive 6x? Ethan already said it's plus 2. So it's a positive 2. So you're right, plus 2. And again, if you can check it if you want to, if you do 3x times this term, that should give you a positive 6x, which it does right there, right? All right, so then basically what they said is they talked to the area of this court for this game. The area is equal to this expression right here, the 9x squared plus 6x. So you've broken that area down into, the area would be this 3x times the quantity 3x plus 2. Well, all you're really doing there is like area equals length times width, right? For a rectangle. This would be some kind of rectangular court for this game. So if I drew you a little picture of it, it would look something like this. This side would be 3x. This side would be 3x. This side would be 3x plus 2. And this side would be 3x plus 2. That's what you did. So the area in here would just be the length times the width. All right, so let me stop this thing right now. We'll come back and do a second part to this, but I'm going to give you some of the problems to start. So let me stop this.